AI agent cost is not just about the token cost. It is the cost of the full workflow that is needed to complete the task. In this video, I will show you why AI agents become expensive and how to control that cost in production. Let's get started. AI agents look simple from the outside, but one request from the user can become a full workflow behind the answer. Okay, so if you see on the left hand side, a user like you or me sends a message to the agent and gets a response from the agent. And it feels simple, right? There is one message and one answer. But this is what actually happens on the right hand side. The agent may break the task into steps, it may process the information, it may use external systems, check the results from the external systems, it may even fix mistakes. Sometimes it may ask for approval, and only after it does all this, it produces the final answer. So the cost does not follow only the final answer, but the cost follows the full workflow behind the answer. And that is why agent cost is different from a simple chatbot cost. Now, let's make this concrete with a simple refund support agent example. Now, imagine the user asks, check my refund status and escalate it if needed. Now, from the user's point of view, this feels like just one request, right? But behind the scenes, the agent may go through multiple steps. So, first, it has to understand the request. Then it has to decide what information is needed. It may look up some additional information. It may use tools to interact with external systems like the order system, the refund system. It may decide if the escalation is needed. If it's needed, it will draft the escalation. It may even wait for the approval. And only after it does all this, the user gets the final answer. So the user asks just one prompt or a request, but the system worked through a full workflow, right? And that is the cost problem. This is why the right question is not just about how much does one model call cost. The better question is how much does it cost to complete the whole task? Now, let's break down what actually makes an AI agent expensive. Okay. Now, the model cost is just one part of the equation. In production, agent cost usually comes from four broad areas: the model, the data and tools, the reliability and runtime, and governance and quality. Okay, now let's go through them quickly. The first bucket is model work. Now, every time the agent calls the model, there is cost. But the model is not only used for the final answer, it may also be used to reason, to plan through a task, to choose the right tools, and to interpret results. And this is what we call as the planning or the reasoning cost. Then there is model generation. This is the text or structured output the model produces, and it could be a final answer, it could be a draft message, or it could even be tool arguments. And this is called LLM inference. Okay. And inside the inference, the main cost drivers are input tokens and output tokens. Input tokens are what you send to the model, and output tokens are what the model generates back. Then comes context growth. Okay. Now, as the agent works through a task, the prompt can get bigger and bigger. It may include the user request, the system instructions, the conversation history, the tool results, and so on. So, the more context you keep passing into the model, the more expensive each model call can become. The second bucket is data and tools. Most useful agents do not just answer from the memory. They need to look things up or take actions. If the agent searches documents or knowledge bases before answering, this is RAG, right? Retrieval augmented generation. That can add cost through embeddings, vector search, re-ranking, memory lookup, and storage. Okay. Then there are tool or API calls. Now, a tool may not be a model cost by itself, but it is still part of the agent cost. It can consume API quota, trigger infrastructure change, query a database, or it can perform other actions. And this adds additional cost. And this is where the agent loop comes into picture. The agent may call a tool, read the result, decide the next step, and call another tool. This is called the agent loop or the plan, act, observe loop. Now, each loop can act like a multiplier. Each loop can add another model call, another tool call, more context, more time, right? And this ultimately adds to the cost. The third bucket is reliability and runtime. Now, this is where production becomes very different from a demo. The first cost source is retries and failures. Now, in production, the agent may fail, retry, fall back to another path, right? And each of this retry can add more model calls, more tool calls, more latency, and hence more cost. The second cost source is runtime infrastructure. Now, the agent has to run somewhere, right? It has to be hosted somewhere to serve requests. So it may need a server, it may need containers, storage, databases, etc. Okay, and that adds to the cost. The third cost is observability. Now, to control cost, we need traces, logs, metrics, token tracing, etc. And all these add storage and monitoring cost. But without them, you cannot see where the money is going. So they are required, but they have to be optimized so that they don't end up becoming costly. The fourth bucket is governance and quality. Okay. Now, as soon as the agent can take action, you need controls around what it can access, what it can do, and whether the output is safe to use. So, the first cost source is security and policy checks. Now, the agent may need authorization, access control, policy enforcement, guardrails before it can complete the task. Now, these checks are important, but they add extra processing, system calls, extra tracking, and hence extra cost. The second cost source is human review. Now, for high risk actions like refunds, emails, payments, a human may need to review or approve the action. And that reduces risk, but it adds time, operational effort, and workflow cost. So, this also has some cost to it. The third cost source is evaluation and testing. Now, before you trust an agent in production, you need to test whether it answers correctly, uses the right tools, handle failures, and stays within acceptable cost and latency. But this is not a one-time cost. Every time you change the prompt, the model, or the tool, you may need to test again, right? So evaluation is important, but it comes at a cost, right? So it has to be again done smartly. Now that we know where the cost comes from, the next question is how do we control it? So the important point is you do not control the agent cost only by choosing a cheaper model. You control agent cost by designing an effective workflow. There are four main areas where we can control the cost. First is measure and govern. Second is to reduce the model usage. Third is to optimize the data and tools. And finally, to control the execution risk. Now, let's go through them one by one. First is to measure the cost per completed task. So, do not only track the cost of one model call, track the cost of the full task. For example, how much does it cost to resolve one support ticket, to process one refund check, or to complete one research task? This gives us the real unit economics of the agent. Next, set budget and quotas. This is about setting overall spending boundaries. For example, you can set daily spend limits, user level quotas, rate limits, and even kill switches. The agent should not be able to spend unlimited money just because it got stuck or usage suddenly increased. Finally, compare cost versus quality. The smartest workflow is not always worth the cost. So the goal is to find the lowest cost workflow that still gives acceptable quality. The next area is about reducing the model work. Okay, so the first approach is to route requests by the complexity. Now, not every request needs a full agent workflow. A simple FAQ, frequently asked question, may just need a cached answer. A status lookup may need a direct API call. Only a complex case may need the full agent. Okay, so send simple tasks through simple paths and reserve the agent for tasks that actually need reasoning. Next, use smaller models. Now, a large model may be useful for complex reasoning, but you may not need it for classification, routing, or extraction, right? So, choose the model size wisely. Next is to cache repeated context. So, if the agent keeps using the same instructions, policy documents, or common context, cache it wherever possible, which helps to control the cost. Finally, another way is to shrink the context. It's also called as context compression or context compaction, where we compress the past conversation, probably by using a model to create a summary, and then attach it with the more recent conversation history so that the context is reduced as the conversation gets longer and longer. Now, the third area to control cost is to optimize data and tools. Okay. So, first is to control the retrieval. Now, if the agent uses RAG, do not retrieve too much information by default. You can control how many documents or results come back. You can control when re-ranking is used. You can even control how much memory is searched. Okay. So we have to optimize the retrieval mechanism. Next is to optimize tool calls. So avoid duplicate calls, batch calls wherever possible, and cache tool results for repeated queries. Also use clear tool descriptions and schemas so the model calls the right tool with the right input. And finally, avoid agents when the workflow is simple. So if the task is a basic task like a simple lookup, an FAQ, or a single API call, a deterministic workflow may work much better. So sometimes the best way to control the agent cost is to not use the agent where it's not required. Now, the final area to control the cost is control execution risk. So, first, set the execution limits. Now, this is about controlling how far one agent run or invocation is allowed to go. So, we control or we limit the number of steps, retries, tool calls, tokens, and so on. So, if the agent cannot complete the task within those limits, it should stop, fall back, or ask for help. And this leads us to the next approach, which is to prevent loops. If the agent keeps repeating the same step or calling the same tool again and again, stop the workflow. Next is to manage the tracing. Now, logs and traces are useful, but you may not need to store every detail forever. Keep just enough visibility to debug and govern the agent, but do not let observability itself become an uncontrolled cost, right? And finally, use human review selectively. Low risk actions can often be automated. High risk, regulated, or low confidence actions should go through the approval. Okay, so we have to use human in the loop selectively because it also comes with its own cost, right? And as we scale the agent, it leads to operational cost. So the summary is simple. We control the agent cost by designing the workflow effectively. Now, this leads to the most important question. When are agents worth the cost, right? Because we just saw that there are so many elements and components that agent may become expensive if not controlled properly. Okay. And for this, a simple way to decide is to ask if the task needs reasoning, tools, and judgment. And if the answer is yes, then the agent may be worth the cost. So use an agent when the request varies a lot. Okay, for example, when users ask different types of questions and the system cannot follow just one fixed path every time. Use an agent when it needs multiple systems. when the task needs multiple systems. For example, when it needs to use tools, APIs, data, or even business systems together. Use an agent when the task requires judgment. Okay, for example, there are trade offs or decisions to be made. Use an agent when the workflow has to adapt to new information. For example, when the next step depends on what the agent observes. And most importantly, use an agent only when the business value justifies the cost. Okay? But avoid an agent when fixed rules are enough, right? In that case, rule based automation may be much better. Avoid an agent when the task is just a simple lookup or an API call. A direct API call is usually cheaper and more reliable. Avoid the agent when the task is high volume or repetitive. In that case, just optimized for the unit cost. When the output must be exact, it's best to avoid the agent and use a deterministic workflow because it's usually much safer. And then sometimes when latency is a big concern in real time applications, you may want to avoid agents because they use dynamic planning, reasoning, and loops. So the thumb rule here is start simple and then add agency only when it creates value. Okay. Otherwise, you're paying agent level cost for a problem that did not even need an agent to start with. Great. That's all for today. I hope by now you have a good understanding of what constitutes or what components make up the cost of an AI agent and how to control that cost with different approaches. If you found this video helpful, do like, do subscribe, do comment, and stay tuned for the next set of videos. Thank you.